Hi everyone. Our topic is the image sharpening technology. This is the team leader Chen and those two members Lu Zhenyu and Liu Guoyun. Okay. Firstly, let's look at some traditional techniques. The first one is on directed first order sharpening, also called Sobel operator. The formula is like this, and the kernel is like this. The convolution kernel of Sobel HD operator is shown in the figure below. Each pixels in the image use those two kernels for convolution. The Sobel operator believes that the influence of neighbor pixels on current pixels is not equivalent. So pixels with different uh, different distance have different weight and have different effect on the operator results. Generally speaking, the greater distance, the smaller the impact. Those two kernels have the largest response to the vertical and horizontal edges respectively, and the maximum values of the two convolution is used as the output bit at this point. The result of the operator is an edge amplitude image, and the result is such like this. Okay, so let's start. We are talking about the robot operator. Also, let's first look at the formula. Okay, and this is the kernel, and it seems like more simpler than the software operator. Okay, and then this is the result. The result. Nestling, let's look at the Laplacian. The Laplacian sharpening image is related to the degree of mutation from the pixel around the pixel to this pixel in the image. That's to say, based on the degree change of the image pixels, we know that the first order differential of a function describes where the function image change that it grows and decreases. And the second order differential describes the speed of image change, whether it increase sharpening or decrease slowing. Based on this, we can guess the degree of transition that can find the pigment of the image based on the second order differential. For example, the transition from white to black is relatively sharp, and the result is like this, and the edge is more clear. Okay. Okay, now let's look at another approach, USM. USM sharpening in Photoshop. Now let's look at the application of image sharpening algorithms in real scene. Photoshop is one of the most commonly used image processing software. There are some image sharpening filters in Photoshop, and USM sharpening is one of the most commonly used ones. The sharpening process is such like this. This is original. X is original pictures, and through the high pass filters, and we get another image, and then we subtract those two images, and we will get the sharpening image. Okay. Then how to implement. So then our question becomes to how to implement the high pass filtering. Actually, Actually, we can actually so-called USM or unsharp mask refers to the use of bird uh, unsharp mask which sharp sharpen the original image. This is mainly because firstly USM obtained bird image by Gaussian filtering or other low-pass filtering of the original image. Then it subtracts the bird image from the original image to get edge image to achieve high-pass filtering. Finally, the edge image and the original image are linearly combined to obtain a sharpened image. We achieve high pass through low pass. Imagine that the difference is the result of subtracting of blurred image from the original image, and this is also the degree, the edge part of the original image. Then the original image plus this difference is equivalent to sharpening. Then we are going to find suitable low-pass filtering. Usually, the simplest low-pass filtering mask is as follows: is so-called mean bird. However, the mean filtering is obviously not very reasonable because the images are continuous and the closer pixels are, the closer relationship should be. Although the mean bird can also make the picture bird. Its bird is not very smooth. The non-smoothness mainly lies in that the pixels that are far away from the center pixel have the same weight value as the pixels close to the center. As a result, the bird effect is same, uh, which is not reasonable. Making the weight value vary with the distance from the center pixels can be achieved by using characteristics of Gaussian distributions. So within Gaussian bird, also called Gaussian smoothing, is a processing effect widely used in image processing software. It's usually used to reduce the image noise and the level of detail. The image produced by each bird um, technology as the usual effect of looking at the image through a frosted glass. From the mathematical point of view, uh, the Gaussian bird process of image is the convolution of the image and the Gaussian distributions. The Gaussian distribution mentioned above is one-dimensional but for images this is two-dimensional, so we need 2D Gaussian distributions. Next, we need to obtain a Gaussian weight mask to convert the image. Suppose our mask is 3 star 3. The left is the XY coordinate of each pixels in 3 star 3 mask. In order to calculate the weight matrix, the value of sigma needs to be set. Assume sigma is equal to 1.5. After performing corresponding to the Gaussian weight calculation on xy coordinate, the weight matrix with a fuzzy radius of 1 as follows. With weight matrix, the value of Gaussian bird can be calculated. Assume that there is a 3 star 3 matrix. The grid value 1, 0 to 215 as follows. Then each pixel is manipulated by its own weight value. Adding 9 value obtained to get the value of Gaussian bird at the center pixel. Then repeating this process for all pixels to get a Gaussian bird image. For color pictures, we need to perform Gaussian bird on the three RGB channels respectively. Subtracting the Gaussian bird from the original image, and we can get the high pass part. Adding the high pass part to the original to finish the sharpening process. Let's look at the effect of Gaussian birds on Photoshop. We choose 1 pixel radius, which means 3 stars, 3 Gaussian masks. The larger the radius, better the burn effect. Finally, better the high pass and the sharpening effect. After knowing the principles of USM and Gaussian burst, let's return to Photoshop. We can see it has 3 parameters. Radius refers to the radius of the uh, Gaussian burst, which the same as the radius in the Gaussian burst setting. The larger the radius, the more the pixels are blurred, and the more edges are enhanced. Threshold refers to the sharpening the pixels if the difference is greater than the threshold. Otherwise, no sharpening is performed. Zero means all pixels should be sharpened, and 255 means no sharpening for all pixels. Threshold help protect pixels that we don't want to sharpen, such as areas with smooth gradients. Finally, finally amount determines how bright or how dark pixels are. Higher values produce greater contrast. Usually, we adjust the value of 3 parameters according to the specific use scenario. Let's try to sharpen the linear with following parameters. This is the original pictures, and this is USM sharpen. Um, and also this is the reference. Okay, thank you for your listening, and this is our project research. Thank you very much.